In addition, the casing and mud programs and the geological section also affect the deviated well design. The geologists or the reservoir engineers should choose the location of the target. The target is specified using latitude and longitude coordinates, or a grid coordinate system, which specifies the coordinates in relation to a reference point. The depth of the target is generally expressed by the geologist in terms of true vertical depth below a national reference point, such as mean sea level. The size and shape of the target is determined by the geology surrounding the reservoir. Smaller target areas require a greater degree of precision in drilling, and so lead to increased costs. The rig should be positioned as close to directly above the target as possible. However, the geological features around the reservoir, such as salt domes and faults, must be taken into consideration. When developing a field from a fixed platform, the location of the platform will be selected so that the directionally drilled wells can reach the full extent of the reservoir. Subsurface obstacles, such as adjacent wells and faults, must be taken into consideration in designing the well profile. Drilling close to an existing well can be very dangerous, especially if the existing well is on production. The proposed well path must avoid all other wells in the vicinity. Finally, the competency of the formations being drilled through must be taken into account in designing the directional well. The kickoff point is often placed immediately below the surface casing. In this way, the build-up section is below the unconsolidated formations that are closer to the surface. In highly deviated wells, the build-up section may be cased off before drilling the long tangent section of the well. The tangent section would maintain the angle into the target formation. Now that you have completed this module, you should be able to describe the general configuration of a well, identify the criteria used in selection of casing setting depths, sizes, weights, and grades, explain the functions and properties of a drilling fluid, describe the types of drilling fluids used and the circumstances in which each type is used, explain why deviated wells are drilled, describe typical deviated well patterns, demonstrate familiarity with the terminology associated with deviated well patterns, identify the constraints in achieving the trajectory required in a deviated well. In this module, we describe the different types and functions of casing and their configurations. We also discuss the different types and functions of drilling fluids and their impact on the design process. Finally, we examined how to use directional drilling to achieve optimal well productivity. The potential well profiles were discussed, as well as how various parameters influence well design. If you're still unclear on any of the objectives, now would be a good time to go back and review.